In this video, I'll be talking about how to exploit a heap overflow using House of Force. The House of Force technique overwrites the top chunk of the heap in order to fabricate a memory allocation that will return an arbitrary memory region. By tampering the size of the top chunk to a very large value and allocating a chunk with an attacker-controlled size, the top chunk can be set to a desired arbitrary memory location, so that the next allocation from the top chunk will produce a chunk at the desired memory location. This results in a write what where condition, which the exploit developer may leverage to achieve arbitrary code execution. Here are some requirements for House of Force. A heap overflow. The top chunk must be reachable by the heap overflow. The ability to invoke the memory allocator at least twice and write data to it. The ability to leak the address of libc base in an ASLR-enabled system or a Pi binary. Here's the methodology. This attack assumes an overflow into the top chunk's header. The size is modified to a very large value. This ensures that all initial requests will be serviced using the top chunk, instead of relying on mmap. On a 64-bit system, -1 evaluates to 0x16fs. A chunk with this size can cover the entire memory space of the program. Let us assume that the attacker wishes malloc to return address P. Now, any malloc call with the size of top chunk minus P will be serviced using the top chunk. Note that P can be after or before the top chunk. If it is before, the result will be a large positive value, because size is unsigned. It will still be less than -1. An integer overflow will occur, and malloc will successfully service this request using the top chunk. Now, the top chunk will point to P, and any further requests will return P. Here's an example of vulnerable code containing the heap overflow that we are going to exploit. We control the size, and we control the data we can write. Here we see we control the size and the data, and over here in the screenshots we overwrite our 0x20 size chunk with 8 Bs into the top chunk. Here's our exploit code for the arbitrary write. Over here, we calculate the delta. We add 0x20 to account for the 0x20 chunk we allocated. We take away 0x20 from elf sim target to stop just before the data of the variable. And here we overwrite the top chunk with a large value. Here's our arbitrary write into the target variable. Here's our exploit code for code execution. Here, we're calculating the distance between the top chunk and the malloc hook. We do libc sim malloc hook -20 minus 0x20 to ensure the allocation stops just before the malloc hook. We then minus that value by heap leak plus 0x20 to calculate the top chunk. Subtracting these two values gives us the difference between the top chunk and the malloc hook. And our heap leak is given to us at the beginning of the program. We exploit the heap overflow for code execution on the bottom here. We overwrite the top chunk with a large value. We write binsh into memory. We call system, and then we pass binsh to system, and then we pop an interactive shell.
Swag, 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 where I don't even know you. Go ahead, get up on my face where I don't even know you. Shorty, if you got a fat ass, I don't need to know you. Yeah, get up on my face, bro, this bitch annoying. Yeah, shit start to boil. Face shots, hit him in the face, give that boy a boil.